welcome to our third installment of Physical Physics. This is Joshua Wenger and Simon Shee, and I'm Samuel Holt. So previously, in DP1, we developed our BRG educational project for 9th grade physics students. We generated our customer needs and target specifications based on a customer survey we conducted of our target market. We also performed some initial economic analysis. In DP2, we started with the conduction of an intellectual property search to generate ideas as well as to protect us legally in the future. We performed product decomposition and concept generation, and we ended with a concept selection and concept testing, which resulted in us selecting 3 different concepts. Today, in DP3, we are covering the design for environment, product architecture and industrial design, as well as our full FMEA analysis on the detailed design. We also have to present a 3D CAD model, as well as our updated and finalized economic analysis. So, in our design for environment, we wanted to ensure we could design the product and produce the product in an environmentally sustainable way. So one of the first things we plan on doing is to eliminate toxic materials in both the product and during the manufacturing process. We plan to use renewable materials such as bioplastics and soft woods in the actual product. We also want to focus on a complex recycling program during manufacturing. And as far as distribution, we plan to use efficient rail transport to get the product to our customers. Simon will now discuss our product architecture.
Thank you, Simon. For the product architecture, our team divides the product into 4 major chunks. The first one is the support. The support will connect all the obstacles and provide the support for each component. We also have the obstacle. It will deliver the ping pong ball and raise the ball for 20 to 24 inches height. For the motor driver, it will provide the necessary extra energy for the system. And we also have the Arduino. The Arduino will receive the inputs from user and send a signal to control the motor driver. During our design, our team mainly focus on to make the product serve a useful function. So the first priority of our team is to design a novel product for 9th grade students. According to the result of industrial design evaluation, the categories that a team spend more times on have a higher score, like the quality of the user interface, the appropriate use of resources, and the product differentiation. And on the other hand, the categories that team spend less time didn't have a high score, like the emotional appeal and the product maintenance. Also, our team performed a full FMEA on our final design. According to the result, the highest RPM value occurred at the 10 gold elevator lift code. So our possible solution is to fix with different code, and we also need to update the instruction to include the resetting code attachment to the basket. And in general, our team will use better materials in our final product and perform more product testing. Then Josh will talk about economic analysis and the 3D model.
Thank you, Simon. So we created a 3D model to help with calculating the assembly time as well as other economic benefits. Our first obstacle is an incline ramp that a ball will roll up, and students must select which hole it will fall into based off of the translation between kinetic and potential energy. The ball will then exit this obstacle and roll into an elevator, which will raise it the required 24 inches. The students in this obstacle must calculate how many revolutions the motor must go through and program this into the Arduino code. The raising of the elevator will also trigger the release of a ball from our third obstacle of the release ramp. This basically allows students to calculate how high the ball must be for the ball to exit at a specified velocity of 1.34 meters per second, which is equal to 5 miles per hour. We then created economic analysis. This is our cost sheet, which is basically a whole bunch of numbers stating how much money we spent on each product. As you notice, we did not use any product molding in this, for this product. Additionally, we broke down this cost into the different sections, specifically the raw material that we would purchase, the processing, both the labor and the power required for the machines, as well as the assembly time and the machine purchases. We spent approximately $38.50 on the material. This includes all the electrical components primarily, and by shifting the majority of our cost to material, we were able to have less of a loan from VTEPs due to the fact that we require less money up front. Additionally, our second largest is purchasing machines such as drill presses and sheet metal forming tools to enable us to produce the products rapidly. Our lowest is assembly, due to the fact that it only costs 50 cents, due to the low number of components within each obstacle. In conclusion, at this point, we have entirely researched customer needs to establish target specifications to ensure that we can produce a product that is relevant for the market, targeted specifically at 9th grade physics students. During concept generation selection, we completed product decomposition and architecture, 3D CAD modeling, FMEA, and concept prototyping. We also completed an intellectual property research, as Sam stated, to ensure the fact that we do not infringe on the AMLO's property rights, and also to gain ideas for the design. We've done extensive economic analysis to ensure that we can make money and produce profit for VTEPs. As a result, we now have a product that we believe could be in stores within a period of 6 months. Thank you for listening to our presentation. Have a great day.